assignment, you will write some simple loops. All loops introduce printout numbers, not adding together input scores or the like. Then it says also from the idea of list.
So what we're going to do is we're going to talk about arrays. But before that, I want to mention, I think maybe it was extra credit, maybe it was part of the assignment, to get that game program we wrote to have a maximum number of turns. And so I want to just kind of flesh that out, you know, and it's okay if you open it back up and you turn it in a day late or whatever, you know, that's cool.
I actually have a question about that.
Okay.
Whenever I got it to run properly, it still kept doing 11 instead of 10 like it should.
Well, yeah. Make that number less than or equal to 10 instead of less than 10 or less than 11 or whatever I had there. Okay, so the game looks something like this. I don't remember all the exact terms, but I think we had a game function and we had some counter. Nope, we're not doing C. Called turn or turns, something like that. I don't remember if we started it off at 1 or 0. And then we had a while loop, while guess, you know, not equal to target, something like that, I think was what we had. Or maybe we just had while game is equal to, you know what, why don't I actually look it up?
I actually have it here for you if you want.
Yeah, let me eyeball it.
I had set it to 9 so that way it goes to 10.
Yeah, so correct is equal to no, while correct is equal to no. Okay. So we had a flag to indicate whether we had it correct or not. And so while correction was equal to no, while we didn't have it correct yet, then we would get our guess and turn it into an int. Something like that. And then we had some if statements. If the guess is equal to the target, yay, do something. And we set correct equal to yes so that it would exit the loop. If the else colon, we had a second chunk of code that looked kind of like this. If guess was less than target, say your guess was too low, and you don't need the parentheses around it. That's another coding paradigm that Python doesn't force, so I could easily go and remove those parentheses. It would still work. If the guess was less than the target, we would say your guess too low. Else, if the guess was greater than the target, we would say guess too high. And somewhere in here, we would have been adding 1 to the turns each time. Did we start turns off at 1 or 0? Probably 0. Doesn't really matter. And then so we had turns plus equals 1 so that we were keeping track. So down here, this is the section that happens if the game is going great, right? This is the section that happens if they make a bad guess. And if they make a bad guess, that's when we want to check to make sure that they haven't exceeded their maximum number of turns. So here, in line with this set of if-else's, we could check that out. If turns are, let's pretend that I'm not going to get this to be running code, but I'm trying to make it look pretty close. If turn is greater than the max turns, greater than 10, greater than equal to 10, you have to play with that, get it to be exact. Then you would print, too many turns, bro. Try again some other time. Whatever. Now we need to bail out of our while loop without setting correct equal to yes, right? Because we don't want to indicate that they won the game. We just need to get out of the loop. And I think we've talked about break statements in loops. If you have a loop that's going something like this, while x is less than 10, and then some special condition, while the guess they make is equal to q, something like that, then you can break out of the while loop. And the break statement will cause it to go past, you know, the end of the while loop and start doing whatever. We can take advantage of that here. We can do break here. All right, now I'm going to go ahead and add my end-if comments and end-if comments and end-while comments, just to make it easy to keep track of things, and the end-def for the end function comments. All right, so I think all those line up with their keywords. Well, when it breaks, it's going to jump down to here after the end-while statement. And that's where we can check to see whether they actually got it right or not. Did they ever guess it correctly? If they said it correctly, then correct will have been set to yes. So if correct is equal to yes, yay, they at some point in time they got it correct. Print congrats, you are a winner. Else, that means that they never got it right because we broke out of the loop before they ever got it correct. And there's more than one way to do this. I know Josiah's got a slightly different way. Print.
I used the previous system, that's why.
Yeah. Nope. Play again, please. And then you might put your little pause statement, you know, input, you know, hit enter to continue. That kind of thing. And I think we had a return statement down here at the bottom. Something like that. Okay. So that is how you do it. In this section here, if the guess is not equal to the target, that's where you want to add your code. You want to check to see if the turn is too high. And if the turn is too high, you're going to tell them so, and you're going to break. Break means exit the while loop. Go to the first statement after the while loop. That gets you out of the loop. Hope that makes sense. We have talked about break. Thumbs up or thumbs down on that?
I don't think we ever went over it in class. I just found it off of Google.
Yeah, then we need to talk about it.
I just found it to be like a way easier way to just stop the loop.
Yeah, we absolutely need to talk about it before we go to arrays. So we're going to talk about the break statement. You may as well fire up idle. Let's all play with the break statement together. Okay, so you use the break statement to bail out of a loop early. So what if we were going to add up 10 numbers that the user typed in, but we wanted to give them the option of quitting early? They type in Q or something. We want to let them get out. Because what if we don't want them to be forced to enter all 10 before they quit? Or what if we don't even want to set a maximum number? But anyways, let's do that. Let's make a little loop that'll count from 1 to 10 and then ask for input. But if they enter something special, then we're going to bail out of the loop. So for x in range, starting at 1, going 11, because we want to count from 1 to 10, counting by ones, let's print enter score. I'm going to use that fancy formatted technique that we did. %d, enter score %d, or Q to quit. Like that. But since I have this placeholder, I need to fill it in with a dot format. And that's not how you do those. I gave you the wrong one. We use these as our placeholders. My mistake. These are a pair of square braces. Right there. Enter score or Q to quit. And then after the quote, not a comma, but a period, dot format, and we're going to print X. And X inside the print format will fill in our placeholder. Do you have to do your prints that fancy? No, you don't. Okay, so let's get our score. Score equals input. But before we convert it to an integer, we're going to check to see if it's equal to Q. And if it is, we're going to bail out of the loop. If score equals quote Q, we're going to just print out some message. Okay, stopping. Something like that, and then we'll break. Now I'm not going to add in the rest of the code about creating a total and adding everything to a total. Yeah, we could. If we were going to do that, we would want to initialize the total to 0. That's our accumulator. And if score is not equal to Q, we'd want to add 1 to it. So up there above our for X statement, we're just going to set total equal to 0. That'll be our accumulator. Total equals 0. And if the score wasn't equal to Q, I could put this in an else, but it's not necessary to. What do I mean by that? If we didn't break, we I'm going to put it in an else just to kind of make everything look the same. Okay, so else, if we get here, score did not equal to Q. And in that case, we're going to add, we need to convert it to a float before we can add it to our total. So at this point, I'm going to do score is equal to float score, and then I'm going to add it to total. Score equals float score, float parentheses score, and then total plus equals that score. I'm going to add an end if there. I encourage you to add these comments. You don't have to. And an end for underneath. And then let's print the total down at the very bottom. So the last thing I'm going to do is use another one of those formatted print statements to print out the total. I don't even have to get that fancy. Let's just do our old style print. Print total equals, end quote, total. That's good enough.
What would you type if you wanted to count down? Because for X in range 1, 11, 1, you're counting from 1 to 11 by 1.
Right, if you want to count down like from 10 to 1, then let's start it at 10. You have to go 1 past, just like we had to go 1 past while going up, so you'd make it 10, 0, minus 1. That'll count it down 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Save it. July 16.py. Alright, that has half a chance of working. Let's see if I have any syntax errors. Inner score. Oops, it didn't fill it in with a number. What did I do wrong with my placeholder? Gosh, I thought I knew what I was doing. Format print Python. Let's go look. Oh, it's curly braces. What do you know? All right. Replace those square braces with curly braces and it will work. So here where I said inner score, just put curly braces there. So I just had to make a fix to that line. Don't put those stars there, the pound signs there. They're just a key in. All right, so inner score 10. I'll type in a number, 30, 9, 20, 10, whatever. And then I'm tired of doing this. I don't feel like adding all the numbers in. I'm going to type in capital Q, and it says, OK, stopping. So the break statement bailed it out of the while loop or the for loop early. And it doesn't matter what kind of loop it is. It'll bail it out. It'll exit a for loop, it'll exit a while loop. Sometimes you can use a return statement to exit a loop early because it'll just exit the module. But this isn't a module to begin with. We don't have a DEF function name up at the top. Okay, so that's our break statement. You know, the simple. Let's do the world's simplest one. Int, no, int. I'm slipping back into Java. X is equal to 0, while X is less than 10. Let's print out X, but then for some reason, we really don't want to go all the way to 10. If X is equal to 5, colon, I forgot the colon, break. And so when we run it, it would count 0, 1, 2, 3, 4, 5. Now you're not going to normally write it like that, but that's just, you know, like boiling it down to its core essence. And what do you mean you wouldn't write it like that? Because if you really wanted it to stop at 5, you'd change your while logic rather than throw a break in. But that technique is useful for something like this. You can do while true, and that's just an infinite loop. But if you put a break statement somewhere in here, tucked in an if, then it no longer is an infinite loop, right? There's some way for the loop to exit. And I've been avoiding doing that so far because it's not shown in the book. But I find it actually an easy way of writing these things. So I'm going to delete this, but while true, you know, x is equal to input, you know, and then x is equal to, if x is equal to q, quote q, then break. Something like that. That way, there's no upper limit to the number of times it can run. And you don't have to set a flag, you know, correct is equal to, or, you know, that kind of thing. It's kind of a shortcut way of writing one of those loops where you're getting data, but you want to let the user stop any time that they want to stop. Enter -1 to quit, enter q to quit, that kind of thing. And I'm going to comment that one out because we don't have any print statements or anything to, and I don't want to make so many things that require input that it's very tedious for us to run. Alrighty, that makes sense, guys?
Yes, sir.
There's another keyword called continue in most of these languages. And what continue does is it doesn't jump down to the end of the while loop. It goes back up to the top of it. So if we had a continue here, it would jump back up and do the print x. And if we had a continue here, instead of a break, it would come back up, add 1 to x or subtract 1 to x and do whatever alteration was specified by that, and then it would run the loop again. So continue causes it to skip the rest of the loop and jump back up to the top, whereas break causes it to skip the rest of the loop and then jump outside the loop. All right, we've used lists a little bit, but that's what we're going to talk about now, arrays. Java doesn't use arrays, Java uses lists. The only difference between, well, maybe not the only difference, the key difference is that lists grow and shrink as you need them, and arrays are fixed in length, meaning once you say I want 10 numbers, that's all you got. We're going to simulate arrays with Java via our excellent skilled programming. But the guy who invented Java decided he didn't like arrays and he did everything as lists, and it does perhaps make it easier to use because you don't have to worry about going past the end of the array. What do I mean by that? What if your array only had room for 10 items but you needed to add an 11th item? Well, you're kind of out of luck if you're using an array because it's fixed in length, or you have to allocate a new array and copy those 10 items in, and all that copying, you know, is kind of expensive time-wise. Not really when your computer's running, you know, 8 billion instructions per second, but it's still, you know, a tangible amount of time. So we're going to learn about arrays, how an array can replace nested decisions. I don't particularly like that slide. Using constants with arrays, searching an array for an exact match, using parallel arrays, and everywhere you see the word array you can think, or Python list, and Python's not the only language that supports lists. C++ and Java, and they all do. Remaining with array bounds, because if you have 10 items in the array, they're numbered 0 through 9. You can't access element -1 in most languages. You can't access anything past the 9. That would blow it up. And why is it 9? Because we start counting at 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 items. It's just that we started counting at 0. That's not specific to Python. That's pretty much universal in all programming languages. 0-based indexing. And then using a for loop to process arrays. So what is an array? It's a series, a list of variables in computer memory. all the variables share the same type and have the same name. What does that mean? Well, to be a true proper array, if you start storing numbers in it, ints, you need to have ints in every element of the array. If you start storing strings in there, you know, the things in the quotes, then you better only put strings in your array. That's the classic textbook definition of an array. Now, Python lists are more flexible, and you can store ints and strings and floats and turtles all in the same list, but we're learning about arrays. Each variable has a different subscript. What does that mean? Well, you know, if you create a list of names, I'll put that over here in our notes. You know, names is equal to square brackets Joe, Bob, and Sam, like that. They all have the same name, and they're differentiated by their index number, also known by their subscript. So if you print name subscript 0, it's going to print out Joe. If you print out name subscript 2, which one's it going to print out?
Sam.
Yep, that's Sam. And 1, of course, would be Bob. And printing out name subscript 3 would cause a runtime error. Stops the program, because there's only 3 elements here. So the way you think about it is that your subscript, your index number, can be between 0 and n-1, where n is the length of the array. But they all have the same name.
Wait, so skipping 1 wouldn't break it either?
Well, it won't break it. Why did I skip 1? I just didn't bother putting it in there. It's probably stupid logic to skip 1, but it's not going to break it.
It would just print...
It would print Joe and Sam.
Yeah.
Exactly. Logically, it might be broken, but it's not going to actually crash the program, unlike that one. So that would print out Joe. That would print out Bob. And that would print out Sam. All right, this is the 3rd time my phone is wrong. So, you know, if I gave you this array right here, names is equal to Joe, Bob, and Sam, I could easily ask a couple of questions about it. What is the name of the array? What is the length of the array? What is the type of the array? And so the name of the array, I always hate calling it name and then names, but whatever. The name of the array is names. The length of the array is 3, and the type of the array is string. And let's say that I gave another array, ages, and we're going to put 3 numbers in there as well. Joe is 25, Bob is 17, and Sam is 50. All right, and so the name of the array, the length of the array, and the type of the array. Well, what's the name of this array?
Right.
Let's call it ages. What's the length of that array? That's the last item in it. The length of it is, how many elements are in it? 3. And then what is the type? Well, those numbers all look like ints. Okay. Now the way I've set this up, these are actually what are known as parallel arrays. Parallel arrays are when you have 2 arrays where they're conceptually united by their index number. If I copy and paste this one right down here, and I copy and paste this one right down there, we can kind of see the commonality between them. Joe is 25, Bob is 17, and Sam is 50. So I'm going to give a definition here. It ought to be close to what the book says, but it probably isn't. Parallel arrays are arrays of the same length where the elements are conceptually linked by their index number. And we could put more in there. You could have an element, you could have an array of first names, an array of last names, an array of addresses, an array of, monthly salaries. Each one of those would be a separate array. They'd all have to be of the same length. So if we wanted to print out the names and the ages, you just have one counter, one index. Something like this. You need a for loop though. For I in range 0, because all indexes start at 0, up to the length of the names array. I could have just hard-coded in 3, but what if we added more names? So I'm going to use this built-in function to get the length of the array. And then I would print out the name, names, subscript I, comma, ages. And we'll do this in our real code too. Ages, subscript I. And so when it ran, it would print Joe, 25, and then what's the next line going to be? Yeah, it's going to be 17, and what's the name? Bob. Bob, and then 17, and the last one's going to be Sam, 50. Yep. So that's what that loop would print. So they share the same name. They must be of the same data type. Dropping the idea of parallel arrays. The array carries the same name, like ages or names. They must be of the same data type, and every variable in it, which is more technically called element. Every element in the array has a different subscript. So an element is an item in the array. In a true array, the array elements are contiguous in memory. So if in byte number 1000 is name number, name Joe, then in a certain number of bytes after that, contiguous with them in the same length, is name, Sam, and then name Bob, and then name. So it's all nice and neatly arranged in RAM so that when it's being processed item by item, it's lickety split. It's just that the array is the fastest data structure for holding a list of data. But Python is not focused on speed, it's focused on easy usability, so you can't guarantee that the elements are going to be all contiguous in RAM, but they are contiguous index-wise. 0, 1, 2, 3, 4, 5. So subscripts are indexes. That's the position number of the element, the item. Starts at 0 and goes 1 less than the number of elements. N minus 1, where n is equal to the length. It's a subsequence of integers, right? Because if I had these 3 names and I said print out name 1.5, that's a ridiculous idea. What's it going to print out? You can't do that. They're whole numbers only. Adding data values is known as populating the array. If you're going to fill in the data in an array, it's called populating the array. So price is 0 is occupying a certain space in RAM, and immediately after that is prices subscript 1 and then prices subscript 2. Now what's the rest of this? We don't know. Computer has a lot of stuff in its memory. It's got all the programs it's running, all the data those programs uses, but in an array you're guaranteed that for a little while all the data is contiguous and contains your data. So the characteristic, it's a list of items stored in contiguous memory. I may just cut and paste this stuff, but then that would be hard for you to type it all. How many of these things have I done? No, I haven't done them. So let's list off the characteristics of an array. Array characteristics. That's not the one I wanted to grab. That's the one I wanted. All right. What's an array? A list of data items. Contiguous in memory. Contiguous in memory. Each item is an element. Same data type. They share a common name. And you access them. They are, quote, differentiated from the others by subscript. Accessed by subscript / index, two synonymous terms. And the subscripts start at 0 and go up to 1 less than the length of the array. And lastly, every element can be used in the same way as a single element of the same type. So if I wanted to add up two numbers in my ages array, I could do that. Now, this is silly, but suppose I wanted to do this. Total ages is equal to ages subscript 0 plus ages subscript 1 plus ages subscript 2. Right? Each element in the ages list, in the ages array, is an int, so I can just add them up like that. Just like they were specific values stored, you know, x total whatever is equal to x plus y plus z. You know, x plus y plus z are numbers, so are ages 0 plus ages 1 plus ages 2. Now that one's nebulous enough that I'm going to leave it off our characteristics. Making a minor correction to my list here. An array is a list of data items. All right. I hate this slide so much I'm just going to skip it. How can an array can replace nested decisions? I said I was going to skip it, but yeah, I'm going to mention it. Nah, I'm skipping it. Sorry. You can read it if there's a mind tap question over an array replacing nested decisions, and that's true, false, say true, or whatever. Wow, complicated topic.
Can you go back to the notes real quick?
Yeah, sure will. Especially while we're skipping pages into PowerPoint. Alrighty, using constants with arrays. You use constants in arrays with a couple of reasons. To hold the size of the array, you can use a constant. You know, the max number of ages, max names. You know, I have 3 in there, so max names is equal to 3. As the array values. Yeah, whatever. When I said ages is subscript, you know, is equal to 30 or whatever I had, 25, that 25 was typed in as a literal right there, which is known as an unnamed constant. 17 is also an unnamed constant. 50 is an unnamed constant. I don't care about using constants as array values or as subscripts. This is the important use. Using a constant to hold the size of the array. In Python, we tend not to do that because we have the len function, which gives us the length. But in other languages, where you don't have the ability to just ask the array for its size and have it cough it up, you store the length of the array in a constant. And that's C, C++ style, where you can't ask the array for its size. I am going to copy that one and put it into our notes. In many languages, you would store the length of the array in a constant. In Python, you just use the len function. So avoid magic numbers. If you are going to start caring about the size of the array, don't do this. Don't do while x is less than 3 because you know that there's 3 elements. Why? Because later on you might go back and add another name and another age. And then you'd have to find every while loop that depended upon that 3. That'd be a good reason to use a constant instead. It's also a good reason to use the len function. So what you would do is where you declare your arrays, you'd put some kind of constant. Num8 names is equal to 3, and then you could do while x is less than num names. It's far better in the languages that support it to do while x is equal to len of names, like that. That way you don't even have to find, you just create your array as long as you want, and then the while loops fix themselves, based on the length of them. This is the Python Java way. Works for both languages. And you have to make sure the subscript remains less than the constant value. If our number of names is 3, we can access elements 0, 1, and 2. Constants are created automatically in many languages. Well, I don't know about this automatic business, but yeah, in Java, when you declare an array of 7, then there's a property of it that sets itself to 7 so that you can ask it for its length and it'll tell you that it's 7. Python's the same way. It knows how long the list is, and so if you call the len built-in function, then it coughs up the length of the array, which you can use for for loops, and also if you want to calculate the average. So for example, if I've added up all the ages, total ages, at some point, I could say average is equal to total ages divided by the length of the ages list, like that. I didn't have to hard code 3 in there or anything like that. I didn't have to put a constant because this language gives us the ability to know the length of the list. Searching an array for an exact match. Sometimes you need to search the array for a specific value so you can do something with it. For example, I had these 2 arrays where the items were linked thematically by their index values. But what if I wanted to edit Bob's data and change his age to 18? It's his birthday. Well, I have to know where he is. I would have to search this array programmatically, find out that Bob is at index 1, and then I could change ages at index 1 to the new value. And so when you start at the beginning of an array or a list and start checking the items until you find it, that's called a linear search. Linear meaning a line. You just start at the beginning and you go to the end. And yeah, you could start at the end and go to the beginning, but it's still the same idea. It's a linear search. So, example, we have a mail order business where our product numbers are 3 digits, non-consecutive numbers. And the customer orders an item. We have to check to see if the number is valid. So we got to start at the beginning and then start checking. Does this number match one of our existing values? You keep doing that, and if you get to the end of the list without having found it, then you know it's not in there. So if we were stepping through here with some kind of loop, if we ever got to subscript 3 without having found a match, then we know that it didn't exist in the list. And so they wouldn't be able to add the sale, We wouldn't be able to change the user's age if they typed in something that wasn't in the list, and so when we searched the list, it didn't ever find it. And if we'd written the loop to do it, then maybe our index counter got up to 4 or whatever, or excuse me, 3, because it can only be 0, 1, or 2. Maybe that's worth writing in code. Let's go do that. Let's go back to our code and let's just put this up at the top so that we don't have to keep entering scores. So names is equal to same kind of business. Just type in 3 names. Joe, Bob, and Sam. And then ages is equal to 3 different numbers. 40, 70, 23, whatever. Now we're going to ask the user for a name, and we're going to search. We're going to use a linear search on the names array to find the index number. We could use a while loop. We could use a for loop. I'm going to use a for loop. I'm going to use I because it's an index. Remember, names don't matter. I could call this Tony Stark for Tony Stark equals 0 to whatever, you know. For I in range 0, len names. I'm going to search from the beginning of the array to the end. And let's check. If names subscript I, oh wait, we haven't even done our input yet. Above my for statement, I need to ask the user for a name. I'm going to call it target. This is what we're trying to match. Target is equal to input, parentheses, quote, enter a name. That's a shortcut for saying print, enter a name, and then using input on the next line. The book will never show that because that's not available to you in all programming languages, but Python gives it to us, so go ahead and do it. All right, so we have for I. We're counting through the array. We're doing our linear search. I'm going to add that as a comment. Linear search. And if name subscript I is equal to our target, we have a match. We have found it. We have found that element in the array. And we can use that index number. Like we could print out that person's age. Print, quote, that person's age is, not sage, parsley, sage, all right, age is, end quote, comma, age is subscript I. And I'm going to add an endif comment and an end for comment. Now, side effect of the way that I've written this linear search is that if more than one name is the same, like if we had Bob in there twice, it would print out ages for more than one array element. Just because more than one would match. And that's okay. We could put a break in there. If we ever find a break, we just exit out. We print out the first person's age, and then we stop. Alrighty, I wonder if I type that in without any typos. Run module, enter a name. I'm going to type in Bob, and it says that person's age is 70. What if I type in somebody who doesn't exist? Run module, enter a name, Billy. It doesn't tell us that it didn't find it. That's not really optimal. Maybe we should have a variable that gets set to true if we ever find it, or that gets set to the index. So above the for loop, I'm going to create a variable, an index, and I'm going to set it equal to -1, but if we ever find it, I'm going to set it equal to I. And then at the end of the loop, if it's still equal to -1, we know it never found it. So found at equals -1. Yes, sir.
It It's in the error code saying age is not defined in my language.
Make sure you don't have that you have age and ages.
That's what I have, ages.
You have S's everywhere? Let me come look. Let me make this last change and then we'll go look. Okay. So what I'm going to do, I'll be right there, is if we find it, if names is equal to target, we're going to set found at equal to I, proving that we found it. And then down here at the bottom, if found at is equal to -1, it means we never found it. Print, that name was not found. So this is kind of our flag. We could have just set it equal to true or false, but the index number, the index position of where it is useful information. We could use that index number later on. We know that person exists, so we could keep track of that index number, and we could change his, his age or his last name or whatever.
I figured it out. I left out an equal sign.
If you have been typing notes directly in your Python script, like, parallel arrays or arrays of the same length, blah, 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 that kind of stuff, that's not valid Python code because it's just comments. You either put a star in front, not a star, put a hash in front of them, or you can start an entire block of comments with 3 apostrophes and then end them with 3 more apostrophes. And it'll ignore that code. So I could have a bunch of comments without putting hash signs, but also it doesn't take that long to go and do that. All right. Everybody. All right, guys, apparently I didn't actually run the code to make sure that it worked correctly. Down here at the very bottom, we had an example of a while statement like that. While x is less than 10, print x. If it ever got to that section of code, then it's just going to print 1,000,000 zeros. Why? Because I never update, I never alter the value of x. Remember the 3 steps of a loop are usually declare your loop control variable, do your comparison, and then alter it. But if x is never altered, it's going to stay 0. So underneath my end if, I need to do x plus equals 1. Otherwise, you're just going to print out 1,000,000 zeros without stopping. So enter a name, Bob, enter a number, 70, Q to quit, and then it's printing out 0, 1, 2, 3, 4, 5. Okay. We all good?
Not entirely.
Not entirely. So let's make sure that we have all of our found out references correctly. We initialize it to -1, and then inside our if statement, when we have a match, we set found at equal to I. And then lastly, we check if found at is equal to -1, then that name is not found. Now found at is not a special word. It could have been anything. That's not a Python word that we could Google up. It's just a variable name. Could call it Fred. Don't make this change. Fred is equal to -1. Fred is equal to I. If Fred is still equal to -1 at the list, I'm going to undo those changes. Python gives us a command for doing a linear search automatically. Just a single built-in function would do the search. You don't have to write, 10 lines of code or 5 lines of code to do it. So if your language has built-in functions for doing searches and stuff like that, it's a lot more efficient to use their functions rather than write your own. But we have to conceptually understand what a linear search is. All right, so that's what a linear search is. And what we're going to do next is we're going to flowchart a linear search. Just the linear search itself. We're not going to do the declarations up here, although I guess we could. Yeah, why not? So I'm going to pop open good old Lucidchart or your favorite programming flowcharting. People who have Microsoft Surfaces or anything with a touch screen usually like to find a flowcharting program that supports the touch screen. Sometimes you have to pay for them. But I'm not cool enough to have a touch screen laptop. So anyways, log in with your Raider Rose. All flowcharts begin with a start. Let's do our declarations. I'm not going to put a separate declarations box. I'm just going to do one for each one. So names is equal to Joe, comma, Bob. And we could even put braces around it, square brackets. Sam. I'm going to do that. Square brackets around the whole thing. Now I'm going to ask for the name to search. No, we need to declare our found at variable. Found at equals -1. Now let's input the name to search for. Except I'm going to call it target, just because our code did. Input target. Remember, if you hold the Alt key down while resizing, it does a better job, or so I say, of keeping it in the same place. Doesn't seem to matter with tilted boxes, it still messes it all up. And you can zoom in by holding the Control key down and spinning the mouse wheel. Or you can just forget it. Forget it. Zoom back out. All right, now we're ready for our loop. Linear searches are done with a loop. So a loop starts off with a shape, the same shape that an if. What is the shape for an if in a loop?
Should be a diamond, right?
Yep, it's going to be a diamond. But I'm not going to make it an if because it's a loop. Now the book wouldn't put the word while, but I will. Not white. While. Or did we make it a for loop? I think we made it a for loop. For I in range, parentheses 0, comma, len of names array. Len parentheses names. And I'm using Control Enter to break my lines to put in character terms there. Doesn't matter if your text exceeds the size of the box. So what do? The first thing we do is check to see if we found it. So inside our loop, once we've jutted off to the side, we're going to have an if. That's not an if. Try that again. If target is equal to names subscript I, we have found it. And so we're going to set our flag. So the yes side is going to be a block, an assignment. Found at is equal to I. And I may even put a comment in my block here. Hashtag we have a match. And then Control Enter. Now this needs to join back up with a no branch. Every if will split off into two ways, and then they'll hook back up underneath. So I just need one of those little circles to provide a junction. I'm going to delete the A. And then I'm going to draw a line going back to my for, like that. That's a condensed version. It doesn't show printing the age. We didn't declare an ages array, you know. We didn't. That's just the search itself. And so underneath this, when the for loop is done, we could use that found at index. I almost don't want to do this though, because I'm going to be scrolling off the screen. I guess I can pause the recording and scroll up and down for those of you students who are here who needs the help. Alright, so the no of the for loop is going to come down to an if statement, and if found at still equals -1, we didn't find it. So underneath the for loop, the line drops straight down, and the decision is if found at equal -1. Then we will print our error message. Print or output name not found. And just like the other if, they need to hook back up in a circle. And let's just put a stop here at the end. All right, there's our flowchart, which inside class I'm going to pause and give people a chance to catch up, so you'll want to pause it at home. The very top of that is just a start, and then the names equals found names is equal to Joe, Bob, Sam, found at is equal to -1, input target, and then we have our loop, our for loop. Okay, hopefully that makes sense. Hope you can see it on screen. So a flag is a variable that indicates whether an event occurred. Technique for searching for an array. Set a subscript variable to 0. We used I for that. And initialize a flag variable to false. We could do that. We could have made our code use a flag instead of a number, instead of using found at. We could have modified, I'm not going to actually make this change permanent. But we could have made this found at is equal to true, false, and then if name is equal to target, then found at is equal to true, and then come down here, and if found at was still equal to false by the time we got to it, we would say that name was not found. Now that's a common programming technique, but the other common one is to set it to -1. Why? Because if we get down here, we'd also like to know the index number at which it was found. And at this point, we don't have the index number at which it was found anymore. You know, we're not sure that I was equal to the index number at which it was found. fact, it's probably not. It's equal to the length of the names. So by using a numeric counter as found at, then we also have access to the index position at which it was found. But set the subscript to 0, initialize a flag to a value to indicate whether it has been found or not, examine each element in the array with a loop. If the value matches, set the flag to true. If it does not match, increment the subscript and examine the next array element. And they show their own little flowchart, but they break out find item as its own function. And notice they don't even provide a flowchart for find item. They just put a little block right here indicating that it supposedly exists. Maybe on the next slide. Yep, there's find item. It's similar to ours, right? They have a flag, except they called it found it, and they set it equal to no. They have an index, which they called sub for subscript. They have a for loop, and in this case they made it a while loop, keep going while sub is less than size. Yes, subscript is less than size. Come over here, check the item number, or check the item, do your comparison. If the comparison matches, we have a match, so we set found it equal to y. And then we add 1 to the subscript number. We keep going. Now the way this is written is it's going to find, it just indicates whether we found it or not. And then we come over here, and if once we exit the loop, when we can do it a little if statement. If found it is equal to y, meaning we found it, great, do something. But if found it was equal to n, we didn't find it. So parallel arrays, as I mentioned, it's two arrays with the same number. They don't have to be of the same types, right? You could have names and ages. Names are of a different type than ages. Each element in one array is associated with an element at the same relative position in the other array. So name subscript 0 matches ages subscript 0. And you look through the valid item array, and when a match is found, you can do something with the other one. We might come up with an array of, grocery items and prices. That would take a little bit more typing, but not too much. We may do that as an example coming up. I'm just going to blue sky an example of a parallel array. At a grocery store, we might have an item number array, and we might have an item name array, like, fine fresh milk, Parquet margarine. We might have an item price. We would have three arrays. One of numbers, one of names, and one of prices. And then our program, scans in the barcode, finds the number, and it would look up the name of it, so it could print out that, it was farm fresh milk, and it could print out the price, that was $2.99, and add that to the total. One might be a fun one to do. So you use parallel arrays. Two or more arrays contain related data, and the subscript relates the arrays. The element at the same position in each array are logically related. I said it somewhat different, same meaning. I said it as the elements are conceptually linked by their index. Either one of them is a perfectly good way to say it. I hope you understand that those two things mean the same thing. Where the elements are conceptually linked by their index, or elements of the same position in each array are logically related. Parallel arrays are very useful. Yes, they are. Improving search efficiency. Technically, the program should stop searching the array when the match is found. What if we have 10,000 grocery items in our store? We don't want to search all 10,000 items. Once we found the right barcode, once we've done the lookup and we found it, we want to exit the loop. And so set a variable to a specific value instead of letting the normal processing set it, and then leave the loop as soon as a match is found. The larger the array, the more beneficial it becomes to do an early exit. We could modify our code so that it would bail out early as soon as the item was found. A break statement would be a great way to do that. Or we could modify our while loop or our for loop in some way to get it to happen. But if I was going to use a break statement, that place that says we have a match, we have found that element in the array, and we print that person's age, we could stick a break right there. If we did, I'm probably going to delete it. Don't know how to flowchart a break. But anyways, you put a break there, and then as soon as it would found, it would exit the for loop. So if there were 10,000 names, but we find it in name number 10, you don't want to search the other 9,990 names. You just want to stop right there. Yeah, take that out. We might have a code example of doing that later on, though. So searching an array for a range match. Programmers may want to work with ranges. Items 1 through 5, 20 through 30. For example, mail order businesses. You read the customer order data, determine the discount based on the quantity ordered. You could have two parallel arrays, each with 4 elements. One array has the 4 discount rates, and one array has the lower end of each quantity range. So say that, at this store, if you buy fewer than 5 items, you don't get a discount. But if you buy 5 to 9 items, you get a 5% discount. And if you order 10 to 15 items, you get a 10% discount. And anything larger than that is a 15% discount. Or 20% discount. So we could have discount, I'm not sure what they called it. Let's go and find out their names for it. Quan limits. Great. Quan limits. The first discount starts at 0, and then at 5, and then at 10. And how many did we say? And then the highest discount, you have to buy 15 or more. And then the discounts. Well, if you buy 0, you don't get a discount. Or, 1, 2, 3, or 4, there's no discount. But if you do 5, you get a 5% discount, so 0.05. And then if you get 10 of them, you get a 10% discount. And if you buy 15 of them, you get a 20% discount. Like that. And then you could iterate through a list, or you could ask the user how many they're buying, and then you could tell them what the discount is. I don't know if that's worth putting in the code or not. I think we'll just leave that alone. Just remember conceptually, you could store a set of discounts by their prices and by their lower boundaries. Anywhere below 5 items gets the lowest discount. 5 to 9 items gets the 5%. 10 to 14 gets the 10% discount. 15 or above gets the 20% discount. And you would just have a loop, but instead of doing an equal to, you'd have a less than, or less than or equal to, that kind of thing. And so if the quantity ordered is less than the quantity of the limits, that might be worth doing.
Now, wouldn't it be just like the same when you did with the Joe, Bob, and Sam?
Okay, pardon me?
Wouldn't this example be just like the Joe, Bob, and Sam example?
It's almost the exact same thing, except we're not going to search for an exact match. We're going to see if it's less than.
Oh.
Right. So if they have a 4, 4 is not less than 5, and so they get the lowest discount. But if they've ordered 6, it is greater than 5 but less than 10, so they get that discount. You got it, though. You got the idea that you do the same kind of loop, except we're not searching for an exact match. We're searching for a range.
We put the equal sign up to discounts, right?
Yes, sir. Absolutely, we do. That was goofed up. So for this one, they decided it'd be more effective to start at the end of the array and to search for the beginning of the array. And I'm getting psyched up about it. Let's actually add this to our code. So if you were typing in all these comments in your PY script, you know, comment them out, do what you need to do. Let's go back to the code. You could just copy and paste what we type. I'm going to type in it again. I think I'm going to put it at the top, as always, so it's the very first thing that happens. We could be putting things like, you know, press enter to continue. Maybe I will do that. I'm going to put that right above our names code. Input, parentheses, quote, press enter to continue. Just so that when we're done with this discount business, we get a chance to pause before we start doing everything else. Okay. So I'm going to call it quantity disk is equal to, and I'm going to make my numbers 0, 5, 10, and 15. And then I'm going to do discounts is equal to, and I'm going to come up with 4 discounts. The lowest discount is 0.00. The middle one is 0.05. The next one is 0.10. And the next one is 0.20, 20% discount. And I think they just gave it a boring name of X. X is a pretty boring name for a variable, but I'm not coming up with a better one at this point. Let me go and look, see if they really did come up with a better one. Nope, they came up with X. Okay. So let's set X equal to the highest value. What is the highest index value here? It's items. The length of our list is 4. So what is our highest index value?
5.
Other way. Right? Because we can access elements 0, 1, 2, and 3. Now we shouldn't hard code a 3 in there. Instead we should use the len business. But for now I'm going to hard code a 3. Or we could put a constant in there and use that. But anyways, let's hard code a 3. X is equal to 3, which is, I'm going to put it as a comment, length of list minus 1. Let's ask the user for how many items they are buying. NUM is equal to input parentheses quote, how many items are you buying? Question mark, space, end quote, semicolon. Do put that space there because it looks kind of annoying if you have to type in something and it's right next to that question mark. People want to add it, their own space, kind of pad it out. We'll pad it out for them. Okay. We have to convert that to an integer. I guess it could even be a float. You know, we're buying 3.5 items, whatever. Num is equal to float, parentheses num. We have to convert our input to a number before we can start doing comparisons. And then since we're starting at the end, we're going to just keep going while the number that we have ordered is less than our discount. Something bugging me about that logic. I better go and take a peek. This is different than how I would have written it, so. Okay. So, while num is less than And we need to use this variable name, quantity disk. I'm just going to copy that, make it easy for me to type it. Copy quantity disk, Control C it, come down here, Control V as in vehicle to paste it. While the number we have ordered is less than that index value, then x is equal to x minus 1, or x minus equals 1. And then by the time we get down here, this is going to blow up. I've made a minor error. No, maybe not. Let's just run it and see if I've got the logic right. Now we're going to print out the discount for that. Print your discount is, in quote, comma, discounts with an S, subscript X. I almost wish we hadn't typed this code in. I liked it better when you just had conceptually the idea that you were looping for it and looking for a match. They've kind of optimized it to the most efficient one possible, but that made it look different than our linear search. You know, and sometimes just having the concept is better than seeing the code and letting that confuse you. All right, I'm going to run it and see if it works. How many items am I buying? I'm buying 10. No, I'm not. I'm buying 9. Okay, I've done something wrong. Oh, you see that line here, while num less than quantity disk? Quantity disk is an array. I can't just compare it to the whole array. I have to specify which one with the subscript. So qty disk subscript X in subscript. I just changed that line. I'm going to mark it with a couple hashes so you can key in on that. That's the line that I changed. Hopefully it'll work now. How many items am I buying? 12. My discount is 10%. That looks right because I was between 10 and 15, so I got the third discount. All right.
I'm missing something here.
Let me come look. All right, so where it says x is equal to 3, that's pretty lame. Because why is it 3? Because we're searching backwards to the list. And so that's index, that's subscript 3, that's subscript 2, subscript 1, subscript 0. But instead we're going to make this len quantity disk minus 1. So delete that 3 and type in len parentheses and then discounts in parentheses. It's still going to be 3, but if we went and added more discounts, they get a 99% discount if they order, you know, a million of them, whatever, you know, we could do that. Just to make sure it works. All right, how many items am I buying? I'm buying 100 items. I should get the maximum discount, which is 20%. Oh, well, what do you know? Oh, because I forgot the minus 1. Derp. Okay. One more fix here. I'm going to just remove the comment entirely, but it should be len discounts minus 1 because the length of the list is 4, but I needed to get down to 3. Because the available subscripts, the accurate subscripts are 0 to n minus 1, where n is equal to length, so we're doing length minus 1. Alrighty. Onward and upward. So remaining within array bounds, every array has a finite size. The number of elements in the array. Also the number of bytes in the array. And so arrays are composed of elements of the same data type. Elements of the same data type occupy the same number of bytes in memory. The number of bytes in the array is always a multiple of the number of array elements. I'm going through this pretty quickly. If you see a question about it in the test, in the MindTap test, look it up more carefully. And then access data using a subscript containing a good value, a value that accesses memory occupied by that array, which is 0 all the way to n-1, where n is equal to length. Otherwise, you're reading past the end of the array. That could be completely invalid data. When I say it could be, it is. It'd be in most languages will cause it to crash. And those languages that won't cause a crash, if you read past the end of the array, you'll still get invalid results because it doesn't contain anything that's in the list. If we were looking at our code and we were trying to check for name number 5, print out name number 5, well, that's 0, 1, 2. There is no name 3, there is no name 4, there is no name 5. So it could not print out a valid value if we tried to print it out. And it would probably crash the program in some languages, including this one. It absolutely would. In the C and the C++ programming language, it doesn't do that bounds check, and so it would print out garbage. So if something is in bounds, it's a valid subscript. It's within the acceptable range. Out of bounds is not within the acceptable range. I keep saying a range. Acceptable range for the array. Like you use a negative number. Or you use a number that's equal to the length or greater. So an invalid array subscript is a logical error. It's a runtime error. When an invalid subscript is used, some programs stop the execution and issue an error. Other languages go ahead and access a memory location outside of the array with unpredictable results. So the program has to prevent bounds errors. You have to make sure that you're using valid bounds. So to improve a program, you can add a test to ensure that the entered subscript is valid. Like if you're displaying a list of items and you're asking the user to pick an item, but if they type in a number that's too large, you want to make sure that you detect that. You use some kind of if statement. If item number greater than or equal to length of array, you better not use it. You could display an error message, or you could use a default value, or you could keep asking the user for a new value until it is valid. So using a for loop to process an array. A for loop initializes the loop control variable, it compares it to the limit, and it alters it. We've been doing that a little bit. Especially convenient when you're processing every element in the array because the syntax is so concise. It forces you to stay in array bounds as long as you set the upper limit of that range correctly. And the highest usable subscript is one less than the array size, which is real convenient because the range statement stops, if the array is 10 elements long, we would do for x in range 0, 10, and that counts 0 to 9. Which is just perfect for our subscripts because our subscripts for a 10 length array are 0 through 9. So pseudocode that uses a more efficient loop to output department names. Wow, we've done an entire chapter in one lecture. The array, but that's because we did some of this stuff last Wednesday. The array is a named series or list of values. They all have the same data type. Each element is a different subscript. You use a variable as a subscript. Constants can be used to hold an array's size. To search through the array, you initialize a subscript. You test every element for a match. And when you find a match, you set a flag to indicate that it is found. That's what we were using found@at for. Parallel arrays are when each element in one array is associated with the element in a second array. For range comparisons, store either the low or the high end value of each range. That's what we did with our discounts. To access data in the array, you use a subscript. It has to be a valid subscript. If it's out of bounds, it'll blow up, or it won't blow up. That's even worse. That's a silent error. The user doesn't know that the program is using invalid data. And the for loop is a convenient way for working with arrays. You go from beginning to end, 0 to whatever. All right, let's go look up our homework for today. Why don't we pause the recording as well? All right, so for Chapter 6, you will do some simple array work. Create an array called heroes. Place a list of 10 characters, book heroes, comic, movies, TV shows, whatever, personal heroes in your life, I don't care, into the list, and then print them out with a for loop. In Python, we use for I in range. And then print them out with a for each loop. We didn't mention a for each loop this time. Okay, we need to do a few more code examples, or at least we need to do it in nodes. So let's come up with an array called animals. Animals is equal to quote, or square brace quote, dog, end quote, comma, cat, end quote, comma, pig, end quote, comma, horse. And let's print that out each way. Let's use a for range loop and then a for value loop. So for I in range, starting at 0 and going up to the len animals list, always increasing by 1. And remember, you can leave off the 0 comma and the 1 if it's just starting at 0 and going up by 1s. So we could do this. We could take out the 0 comma. We could delete the comma 1. I'm just going to put that as a comment out here. For I in range, len animals would work just as well. We could be putting this right in our code. I'm just going to cut that stuff and paste it. Nah, I'm going to leave it in the notes. All right, and let's print out, print, quote, animal, animals with no quotes, subscript I. That's a range-based for loop. What did they call it? Let me tab over and see it. And then let's print it out with a value loop, also known as a for each loop. So I'm going to add some comments. This is a range-based, parentheses, index-based for loop. And now we're going to use a value-based for loop. Syntax for that is simpler. For v in animals, colon, print v. Well, that sure was concise. You can see why you might want to use a value-based for loop. Just because the syntax is so darn concise. What are the drawbacks of using a value-based for loop? Also known as a for each loop. You don't have an index number. Doesn't work for parallel arrays because parallel arrays, the items are logically linked by their index number. You can't change the value as you go through it. With an index, you could, modify the values if you wanted to. As you were peeking at the array, as you were accessing the array, you could change the values, but not with a value-based for loop. V is just a copy of the value. It's not the element of the array itself. I guess I'm going to add those as comments as to advantages and disadvantages of a value-based for loop. Advantages. Syntax is clean and easy to write and read. Disadvantages. You don't use an index number, so you can't change the element or use parallel arrays. All right, so I'm going to write some code and I'm going to want you to flowchart it. Here's what the code's going to look like. Here's what it does. Print all I want to come up with a cool one and I'm not doing it. Yeah, why not? All the even numbers between 0 and the value the user picks. So the user has to enter an upper bound. So I'm just going to call it bound is equal to, well, let's print our message. Print, what is the upper bound? And then underneath that, we're going to ask for that. So bound is equal to input parentheses. And by the way, there can never be anything on the right-hand side of the input. You can't do this. Input parentheses this is invalid. Can't do that. It has to be in the other order. Have to put this on the other side. Then we have to convert that to an int. Could be a float, doesn't matter. Bound is equal to float bound. And then let's have our while loop. We need to initialize our counter. X is equal to 1 while x is less than our bound, or less than or equal to, so that will include our boundary in it. If, now let's check to see if it's even. What's the best way to check to see if a number is even?
Is it a 0 or a 2? Or 0, 2, 4, 6?
Yeah, we need to check to see if it's 0, 2, 4, 6, and the best way that I know is to use modulus, because we can modulus it by 2, and if there's a remainder, it's odd. But if there's no remainder, if the remainder is 0, it's even. So if x mod 2 is equal to 0 colon, it's an even number. Print x. Remember, you don't put comments in your flowchart, even though I'm putting them in my code. And I've made a mistake, same mistake I've made in our sample code that we've been typing in a couple of times. What's wrong with my while loop? I'll tell you the symptom it would exhibit. It would run forever.
Yeah. No break.
I have no update. I would, yeah, a break would work, but I need to update the variable. X plus equals 1. If you don't alter your value, then you're up a creek. Because your steps are always initialize, loop control variable, and then test the loop control variable in your loop, and then alter your loop control variable. And if you miss that step, it's probably got to be an infinite loop unless there's a break in there. And then let's just print done. I'm going to copy this and paste it into our sample code. Then I'm going to copy and paste it into the homework. And by the way, when you're looking at homework and it looks weird, you should always download the homework to view it. Don't just do it in the preview screen, because sometimes it doesn't show it all to you. Sometimes it doesn't show what's in the boxes or whatever. Well, why'd you put it in a box? I don't know. Maybe I should take it out of the boxes. Okay, so I'm going to take that code that I typed and I'm actually going to paste it into my program, just maybe up at the top. And then I'm going to put an input statement down here at the bottom. Press enter to continue. But I'm not going to make that part of my flowchart. So this is going to be the start. This is going to be the stop of it. That's the one time in the comments that you actually do. Okay, let's run it, make sure it works. Prints out even numbers. What's the upper bound? 40. It should print out 2 through 40. Okay, so that works. That'll be the other part of the homework assignment. Alrighty, I want to stop there, but that's leaving class early. So if you want to hang out and talk about homework, let's absolutely do that. Don't just breeze on out of here with, you know, questions still in your head. Are there any questions over what we've done today? I don't ask that often enough. All right. We'll consider
It's
our
already posted.
homework's not posted yet.
Gotcha.
I'm going to modify it with this last part and then upload it. All righty. Lecture over.